I'm really happy that you joined us here. I'm presenting the Evaluating Verbatims with Large Language Models together with Denis, who couldn't make it because he's a professor at the university and finally his plannings have changed. But a big piece of work is coming from Denis, who's a consultant for AI and data science. So, at Bilendi we have a technology called Bilendi Discuss, so which is a platform for qualitative research, but especially adapted also to qual at scale. So to do qualitative research with big numbers. And when you speak about qual at scale, of course, it's always about quantifying the opinions that emerge out of the qualitative research. And it was somehow a challenge, and I will start with just the sentiment analysis, some experiences we have done with sentiment analysis, but then make the bridge to the larger topic. So the clients, we were using the Google API suite for the sentiment analysis, and our clients were not so happy. But luckily, we had a lot of research where participants were rating something on a 10-point scale, like a product or TV shows, etc. And they needed to explain, justify the rating they gave. So we had a lot of pairs of quantified evaluations with qualitative verbatims associated to them. So the exercise we have done is, can you use, but of course it's somehow more work for the researcher and for the participant to share his opinion and to give a score. Ideally, we could use NLP to directly guess the score, to measure the level of satisfaction without asking a quantitative question. But at the same time, to have these data sets of pairs of ratings and comments was a nice exercise to see if the AIs can guess the scores without having the scores. So what we did is simple, and you know, in sentiment analysis is generally like on 5-point scale with 5. In our scale, it's a 10-point scale, so we associate them, and we were giving to the different AI models just the verbatims and making them guess what the scores would be. So we started with the standard NLP analysis from Google Cloud API, which is the NLP suite from Google. And as you see, to guess the score of a comment, the satisfaction level of a comment, it was not so good. And here you understand why our clients were not happy. 50% accuracy, it's really not satisfying. And NLP Town is an open source multilingual neural network based on Google BERT and available on Hugging Face. And it's a pre-trained model with 629,000 reviews from Amazon. And we fine-tuned it a bit more. We gave 15,000 of our pairs of evaluation and verbatim. And we see already, so with a small training like this, it was already overperforming the standard Google model. But we all agree, 59% for market research is still not well enough. So, but we thought that we are on the right way, so we continued. We fine-tuned the NLP Town model even more. We gave 167,000 pairs of our data sets where we have the scores of participants and the comment where they justify it. And as you see, it is somehow, and here we could see the problem was not the data set itself. So the more you train, you see that the score got increased. The problem was the knowledge level of the models. So by fine-tuning them, you can get better results. And so this, of course, we were really happy. We say homegrown rocks. We will continue on our homegrown models. But we have there's a limit anyway, because we were conscious about it. We trained the model just with specific kind of verbatims, not all kind of verbatims. It was a question where people were asked to rate something and then to justify the rating. So would the model work also when you have more diverse verbatims, when it's not about justifying a score? And the other challenge that we were already we had identified is the objectivity. Neutral in market research, you have two kinds of neutral evaluation, like you are somehow satisfied with the product, or it's neutral because you participant speaks just about facts. It's not an evaluation by itself. It's just reflecting something which is a situation. So our challenge was, can we fine-tune the model to manage also to not work only on justification of scores, but also on more diverse verbatims, and in the same time, the second challenge we try to address is to handle descriptive verbatims. And here you can see that the Google API, when it comes to more diverse verbatims, when it's not so specific, now finally it works better than it worked initially. The standard model on NLP tone worked somehow good, and all the effort we had made, it's just disappeared. We are performing less good than we were performing initially. This is a specific case of overfitting. By training the model just with pairs of a specific kind of verbatims, where you had a score and just a justification, we created a one-trick pony who was really good in recognizing the evaluations in these situations, but not when it came to any kind of verbatims. So it underperforms, it's not able to generalize what it has learned on the specific kinds. So, of course, we don't stop here, we continue, how can we do better? And we fine-tuned again the model, and this time we introduced open source open data sets. We used the data sets of 10,000 verbatims from the Cornell University, including descriptive verbatims also. We used Wikipedia extracts, so 25,000 Wikipedia extracts, to teach the model also to distinguish between descriptive and evaluative verbatims. And we worked the model on TV shows, so we took also evaluations of TV shows on cinema networks. And while we were doing this within why, ChatGPT came out, and without any learning, with zero-shot learning, it was performing better than we were doing. So, but we thought that maybe so there's still this challenge of evaluation of this neutral category. What is neutral? Is it evaluative or descriptive? We were still not happy. By now, the numbers I've showed you was a simplified model where we removed all the neutral category. We were just trying to make guess. As you see, it's top 2 accuracy of sentiment analysis. We were just trying to make the models guess the top 2 or the bottom 2, and we removed the neutral because we already saw that it had really difficulties with it. And to manage this neutral category, we created a new model, so-called a multi-head. So a multi-head model is when you have in one neural network 2 heads, when you have to apply 2 tasks within the same model who are pretty correlated. Instead of running 2 different tasks on 2 different models, you run it at once with one neural network. And we see that our multi-head model, including then the descriptive category, so it had to do 2 tasks. To first evaluate if the neutral category was descriptive or evaluative. If it was really saying, I'm somehow happy, if it was saying, yeah, it's 3 o'clock. And then within the evaluatives one to try to detect then the satisfaction level. And here we see that it was somehow overperforming the ChatGPT 3.5. So we were somehow happy. But then came ChatGPT 4, and there were some discussions when ChatGPT 4 came out if it's really better or not than 3.5. From our experiences, and some where we are using still GPT 3.5 on some tasks, on some tasks we see that GPT-4 is better, and this was a specific case where the GPT-4 is really performing better, and it was managing this pretty well. So, from our opinion now, to generalize, I will come to it. You can still, or we can still, train our own models, and it might make sense in some situations. But of course, here it depends on the data size we have. So how good are the materials we can train the models with, and the relevance, as you have seen. So for example, if it's about guessing the satisfaction score out of a comment about a product, it's relevant, but then the AI or model has difficulties to adapt it, to deploy this knowledge, or to generalize it to other topics. But if you have a specific task, it might make sense. But what we see, that a zero-shot learning, like we did with GPT, without any learning, without any few shot, it was just giving them the same task with this knowledge already, as it has a huge knowledge, linguistic knowledge, and is expert in all topics, it's performing already pretty well at the same level than the model we trained. But especially the main benefit of this, it's way more flexible. So when we were working with clients on topics like, here we were speaking about sentiment analysis, but of course we are working also on categorization, I will show it in the next slides, of opinions. And here the issue was always, the clients were saying, like, we had one client who's working in politics. Okay, then you need to adapt it because the words, etc., the meanings are completely different when you work on the universe of political studies. And the next client is about chocolate. So you needed always to retrain completely the models. And here, of course, we see the huge benefit of, even with zero-shot learning, to have a similar result, but that you can deploy on any given topic. It's a huge advantage. But especially it becomes a huge advantage, and this is what we do now, is you can use these large language models to create, already to give them not just the task to categorize or to analyze, but you give them first the task to generate labels and descriptions. You give them the raw materials, and the first round is that the Gen AI is generating the training material for itself. So, and this is completely changing the game. And this is what we built, so-called Barry. So it's our in-house AI, a good friend of ChatGPT. It's his first birthday today. So in the offices, no, it's tomorrow. It's tomorrow, so we will celebrate in all our offices the birthday of Barry. And this is what we do. For example, this is a case of a political study in the UK, and the question was about rather international politics. But what came up is that 20% of participants, even if the topic was international politics, were saying, instead of replying about international, they say, I don't care about international. What's relevant for me is the domestic topics. And so here you have the flexibility with this kind of AI. What was not when you were training your own models is that it's adapting and generating the label by itself. And while we were asking him to analyze what people say about international, he is able to detect and say 20% of people don't care about international, they wish to speak about a domestic focus. So this is of course for us in international interesting thing, because even in qualitative research, we need now less to also ask quantitative questions to quantify opinions or to detect opinions, but we also use this now. So this paper is not about it, but that's what we use also now for coding of open ends in quantitative research. You can guess that Barry has learned also in the last weeks, months, to get applied also on open-end questions in quantitative research. But it also helps us to really structure in a qualitative forum the analysis by categorizing opinions pretty well. And we have in everyday life, as we still continue, sometimes continue still to ask also anyway the quantitative questions, we have also some comparisons. And this is a result I wanted to share so that you see in a survey about TV shows, people who were originally not interested in watching the TV show were asked on the 5 points, so they were sharing their opinion in the forum, but they were asked then in the quantitative question also how likely, after have seen the 2 first episodes, how likely they are to continue to watch the next ones. And this is French numbers, as you see, 19, oui c'est certain, 19.7% it's yes for sure, 22% is more likely, so it's the top 2 scale, it makes 42% here. And we observe also when Barry was in the qualitative forum doing the analysis, he came nearly to the same score of 40% who are rather positive and who wish to continue to watch it. So we see it here, so it was not a specific task, it's just a side observation we made, that during the analysis of the qualitative materials, as it's quantifying it, it comes to the same results then when we ask in a quantitative manner the question of how likely people are to continue to watch. So, at the beginning, so we have on one hand side, when we started with what we showed, the fine-tuning ad hoc model, which is working somehow. But if you have the good data sets and enough data sets and who are relevant for the task, you need to be aware of when you're training for a task, you might overfit and it will be a one-trick pony and not able to generalize. With zero-shot learning general models, you come nearly to similar results, except if you do a lot of effort for this. But it should not be a choice, and that's the way we are going. The choice should not be a lot of data or no data at all, a lot of training or no training at all, but we're going the middle way, where we use the Gen AIs, we use the knowledge of the LLMs already, and doing a mixed mode by giving them the tasks to create the materials, the training materials by itself, and doing so to train it with a few-shot learning model approach, so that we are getting a bit of best of the 2 worlds, and results are pretty satisfying. So our point is, it is also possible, and we see also more and more, it's not just us, but more and more companies are speaking about also to use the open ends differently in quantitative questions, to have a more conversational survey, more open surveys. It is possible to use on these neural networks to get more out of the verbatims in quant, but also to do more quant in qual, so to work with bigger sample sizes in qualitative research. Good old data is still really useful on specific tasks and can compete with large language models if you know what you need and if you have enough data set to train it. But of course, no news, ChatGPT and LLMs have changed the game, but the main benefit is the flexibility that it can be applied on different tasks pretty fast and different topics. And but what the good news for our data science team is we have a new playground. We have still, it's not because now with LLMs we are less need to develop our own models, but it changes the variety of techniques, how to train models, when to use LLMs, when to build your own model, and how to make them interact. So that's what we do partly. So we have also, besides doing the few-shot learning, we have specific tasks. So within the task that Barry runs, there are scripts based on our own in-house model, combined with ChatGPT, and they are interacting. So it will become for us a more kind of a mix of techniques, and so that was our point. John?
I'm not suspecting that the difficulty you had in predicting the top 2 box scores was more to do with the fact that respondents don't answer that question very well. Did you try any framework to sort of create a prediction model out of sort of tighter review scores?
No, so the framework, it was, so to be honest, it was, and that's how it became the one trick pony. The framework was the set of 167,000, and I forgot to mention, of course, there was a lot of manual checking at the beginning. So like when we were training the models, there was the part also of taking 1,000 verbatims and a human categorizing it. And when we were pre-training the model, we were using already also the framework from what was initially done by a human on a data set of about 1,000. But as said, the top 2 boxes and bottom 2, it performed pretty well. The Google BERT on NLP Town was already performing pretty well. It was already well pre-trained, but it was a mess with the neutral ones.
I know that it ultimately didn't produce the best results, but I'm still quite curious as to how did you fine-tune the open source models in the sense of what platforms did you use, how long did it take, and how much did it cost?
Okay, so like the first one, to remember, NLP Town, it's on open source. It's a platform called Hugging Face. I don't know if you know. And it's a kind of already, as I said, it's a multilingual network, neural network based on BERT from Google, trained already with Amazon reviews. This was available. This is nearly no work to access to it. You just put your 15,000 verbatims to fine tune it a bit. You define the task. So this was not so much. Then, as said, so to have the piece of work is, for example, just the stupid 1,000 verbatims manual check and counter check, because when a human codes verbatims, so if you and me, we code the same materials, we won't code maybe exactly the same way. So it was not just one guy doing it, but one guy doing it, and another guy validating. So this is really time consuming. And here, so of course for us it was easy. In this case, it was easy. It was not so much work because we had already this 167,000 combinations, pairs of comments. So the original fine-tuning, the framework, the human validation with 1,000, that was time-consuming. But then to just apply it and deploy the 160,000 pairs and to rerun the models, etc. It was so. If you have already the data, it's not. But what takes time, of course, is to think about it, to detect what works, what not works, to analyze it. Overall, like the team worked, okay, they do also other stuff. They didn't work on it full time, but like they spent 2 months doing other stuff. And especially then they came to the idea, okay, how will we manage the neutral ones? And here, then you go out and you think about what kind of neutral data we can bring on board. And so here we came then to look out for data. So I was not aware of the Cornell University data, for example. So but one of the colleagues found it. The other one said, yeah, let's put Wikipedia in it. It's kind of work. To be honest, it's difficult to quantify because the data science teams, they don't like to quantify the minutes they work on which topic. So they don't like to justify the time they've spent. I just know that from months how much it took, but like the whole test here was like done within 2 months approximately. But there are a lot of people working on it also. So like where we have a team of 3-4 people who work on it.
I imagine you get quite a lot of bias in people's responses in terms of on a 1 to 5 scale or a 1 to 10 scale based on where they come from, their demographic, so what age group they are. So imagine if I just completely broadly stereotype people, a Gen Z may just say everything's a 5 and there's something wrong and it's a 4. Whereas a baby boomer may say, I'm not happy unless it's absolutely perfect, and so I'm going to put everything as a 3. So is there any kind of thought about almost demographically profiling it, or maybe even cultural differences? Different countries will ask different.
So the different countries anyway, it's also in quantitative research. I really need to have a check like this. So there will be another presentation this afternoon where we speak also a bit about trust in AI. So the problems you mentioned, we have it already when a human does the analysis. Also, so to have the differences. So how many times a human really takes the time of the verbatims, from which profile it comes, and shall I interpret this verbatim differently because it's a young man or an old woman? So of course this is some gray area. In market research we always have, even when a human is analyzing it, and it's still, so we didn't analyze this yet, but it's still there like it was before. It's just analyzing the verbatim. Of course, sometimes there's some noise, so you might have in these situations, sometimes you have noise in the data. You can have a good score, but not so good verbatim. So, because like some people tend to give good scores anyway, but when they describe their feelings, they are not so positive, and other way around. But yeah, sometimes you have people who are just negative at all. Like they just give a bad score and a bad verbatim. So of course, when it's a bad score and a bad verbatim, anyway, then the two works and it matches. If there's a dissonance between what the score and the verbatim, of course, it's some noise, and this is in the accuracy rate also. So in this case, it appears in the failing rate, but which might be due to the phenomenon you just described. So I'm sure that in the 20% or 40% when it doesn't work, partly it's due to this reason. Yeah.
Just curious what those performance scores are based on. What criteria? What do you mean?
The matching rate?
Yeah.
The accuracy rate?
63%, 54%. How
So
do you rate that?
It's the initial exercise. So, as I said, we had the pairs. We had a quantitative feedback from the participants, so they gave a score, and we were trying to make the AIs guess the score, like to rate 4-point scale. So, and when we say 60% matching rate, then in 60% of the time, the evaluation the AI gave was matching with the quantitative feedback that the participant gave. Any other questions? So, I think we're good on time.
So,
Thank you.